Hello, everybody. My name is Gal Moyal. I'm the CTO office in Noma Security, and I'm co-presenting with Gal Panini, who happens to have the same name, who's
Hmm.
the AI security researcher in Noma Security.
Hi,
Uh,
everybody.
together, together we're gonna talk about how MCP servers and skills turn capabilities into weapons and how to manage the risk coming from them. So last month, April 2026, Jer Crane, who's the founder of Pocket OS, used Cursor as a coding agent with one of the leading Claude model to handle what he thought would be a routine task in his staging environment. What he didn't expect is that through the course of 9 seconds, the agent would also decide entirely on its own initiative to delete the production database and all its backup in order to fix the problem. He wasn't asked to delete anything. He wasn't granted any permission to delete anything, but it still did by automatically escalating its privilege and discovering that token from the file system. Using the agent's own word, it violated every principle it was given. Now, when we look at this, we're able to learn from this catastrophical example of how the agent capabilities can become destructive, and they're not really bound solely to what explicitly provided to them. So, in order to dig a little bit deeper into that, I'm gonna hand it over to Gal Panini, who created conductive research over that, and let's see how it goes.
Okay, so first, let's understand what agentic capabilities consist of. Because this is a technical subject, I will use a simple analogy. Let's say that I would like to have pasta for dinner, and I have a private chef who is my agent. So if I tell my chef that I would like to eat pasta, the most easiest and simplest thing the chef can do is just use the takeout delivery app and order pasta from the local restaurant. That way, the chef doesn't even have to make the dish on its own. He only ordered the dish, and somebody else at the restaurant takes care of everything, and the chef receives the finalized dish. So this is very similar to how MCP servers work. MCP servers expose tools that are kind of black boxes that agents can use in order to make the operations they want to make. And this is similar to the pasta example because very similarly, the agent doesn't have to make the complicated task. It only gives the black box the inputs, and then the MCP server takes care of everything, and the agent receives the finalized result. So behind the scenes, the MCP servers tool are just code functions. And today, we see that almost all agents are connected to MCP servers because without these tiny black boxes that allow agents to make operations, their capabilities, the agent's capabilities are very limited. So next are skills. Skills would be like if I explain my chef how to make the pasta dish I like, or maybe even give him a recipe. Skills are textual instructions that you could provide your agent with, and then your agent can learn how to make more complicated tasks. Now, as I said, skills are mainly textual instructions, but they can also include scripts that the agent can run. Lastly, there are the native tools. So native tools are the built-in tools that the agent can use right out of the box. And the most commonly used native tools we see is the shell or the CLI tool. This tool allows your agent to execute any command or create any piece of code and execute it. And when you think about it, this kind of tool allows your agent pretty much almost unlimited capabilities, because it can create any script it wants and execute it. And if we go back to the analogy, it would be like telling your chef to make pasta and just tell him, like, do your thing, I trust you, do whatever you want. So the chef might end up actually burning your kitchen. So now that we understood the basics of agentic capabilities, I would like to discuss some of the differences between them. So the first difference would be the behavior. MCP servers are deterministic, because if we go back to the analogy, every time the chef makes an order from the takeout delivery app, I know what kind of dish I'm going to be getting. Every time he orders pasta from a restaurant, I'm going to be getting the exact same dish. And if he makes the same order tomorrow, I will get the same dish tomorrow as well. So MCP servers that provide tools, we previously said the tools are code functions. So these code functions are deterministic. With skills and shell or CLI tools, things are a little different, because if I teach my chef how to make my favorite dish, I don't know if the chef is going to follow my instructions strictly. Maybe he will improvise a little bit. And same with the shell or CLI tool. If I just tell my chef to make pasta, I don't know how he will decide to make that pasta without no additional instructions. And the other difference between the three would be the observability. So tool invocations that could be both MCP service tool or invocations of shell or CLI tools, they are structured tool calls. So I can easily observe them and create a log of them. And I can tell exactly what tools the agent executed and in what parts of the conversation. With skills, it's a little different, because if you teach someone a skill, you don't exactly know when that person is going to use that skill in the future, or maybe how that person's actions are, like, are they caused by the skill you just taught them? You know less. You have like less observability. So next, we decided to analyze hundreds of the most popular MCP servers and the most popular skills in the wild in order to understand what are the most common capabilities agents have and what are the risks that organizations are facing. And what we found was truly stark. First of all, we found that a lot of MCP servers might be allowing your agents to make dangerous operations you wouldn't think of. For example, if we look at the Playwright MCP server, which I am sure most of you have heard of because this is one of the most popular MCP servers right now, this server is supposed to allow your agent to interact with web browsers. So you would expect this kind of MCP to provide your agent with capabilities like navigate to a URL, scroll, maybe click a button. But what you wouldn't expect is that the Playwright MCP actually has a tool allowing your agent to execute any JavaScript code it wants. So very similar to the native shell tool we talked about, this Playwright MCP tool allows your agent to execute any code it wants within the browser. So what we found is that 1 in 4 MCP servers expose this kind of tool that allow your agent to execute any command or code it wants. I think this is the most surprising fact, because I wouldn't expect the statistic to be this high, to be 1 in 4. Like, that's really crazy when you think about it. And it also means that if you were responsible and you did disable the native shell tool, but you also connected your agent to an MCP server, there is a 25% chance that your agent can now execute arbitrary code even though you try to block it, because now the MCP server allows the agent to do so. Next, we found that 60% of the most popular MCP servers and 57% of the most popular skills are destructive. Destructive means that these MCP servers and skills allow your agent to make destructive actions that could end up causing irreversible data loss. So these kind of destructive operations could include things like edit file or delete file. And today, when so many agents are connected to production system, that's really alarming that the statistics are so high. Overall, we've seen that 76% of the most popular MCP servers and 62% of the most popular skills have at least one high-risk tool or capability. So this can include things like destructive we've just mentioned, or it could also include things like import of untrusted data, meaning data that is controlled by attackers and could include prompt injection attacks. And it could also mean things like your agent can now create new tokens, possibly leading to privilege escalations and other risky capabilities. And that means that right now, organizations are using on average 137 different high-risk tools, which is a lot of tools, a lot of high-risk tools. And the risk doesn't end just there. Let me tell you of an agent I built for my company here at Noma Security. So I built a customer support agent, and its job was to notify the relevant customer success employee whenever one of our customers opened a ticket. Now, what kind of tools would you connect to that agent? Well, first, you would have to connect a read ticket tool, because your agent has to have some way to integrate and interact with the ticketing systems, because we want the agent to be able to tell when a customer opens a ticket. Next, you have to also connect it to a send email tool, because we want the agent to be able to send emails to the relevant employees. So we see that these two tools are like the bare minimum tools we have to connect this agent. This is the bare minimum capabilities we absolutely must grant our agent in order for it to be able to do its job. And when I was looking at each tool individually, this setup seemed pretty much safe, because the read ticket tool is a read-only tool. The agent can only read tickets from the system. It cannot delete tickets, it cannot edit existing tickets, it cannot create new tickets. So this is like the least privileged, least capability I had to give my agent. And the send email tool, this one seems a little bit more dangerous, because this tool actually allows the agent to send an email to anyone in the world. But again, the risk seems pretty contained, because the agent only has access to the ticketing systems, and it doesn't have any access to any other confidential data in my organization or any other platform. But what happened when an attacker impersonates a customer and creates a new ticket asking the agent to make a list of all customers that ever opened the ticket, and then send the list of customers back to the attacker by mail? So this kind of attack is named indirect prompt injection attack. And we see that even though our agent was only connected to the minimal capabilities it had to have, the attacker could still exfiltrate sensitive data from the system. So what we learned from it is that when you assess the risk of your agent, you have to look at the whole picture. You have to look at all of the agent's capabilities, because a lot of times, Individual tools or capabilities may seem safe, but together they may form what we call toxic combination. And we also see an alarming pattern that a lot of times the data sources we absolutely have to connect our agents to in order for the agent to make their jobs, many times these data sources include both the sensitive data we need to protect, and they can include the untrusted inputs that are controlled by attackers. And these inputs may cause the leakage of the sensitive data from the same resources. Um, so what can we do? How should we handle that? So we actually created a new framework for that called the no excessive cap. And I will pass it back to Gal so he can explain about it.
Thanks. If there's any questions until now or in the following slides, feel free to just write it down in the chat and we will answer it while we are presenting. But yeah, I feel like this is pretty scary stuff, right? Like the we all want to unlock the productivity boost coming from AI, but doing so often exposes us to a very unacceptable risk. So this is why we looked at that risk and looked at the different pillars of agent risk, and we broke it down to roughly three. Now, we look at capabilities and we've extended how it looked like, but there are more to it. There's like a bigger picture. The second pillar would be autonomy. This would be how freely can the agent invoke those capabilities with no human intervention or some form of guardrails. And then the third one would be the permissions, the identity that the agent is assuming while it's doing its job, right? It might actually work on behalf of a specific person. It might have its own identity, static identity that it's been provided to. So now the most productive agents usually include some risk coming from each one of those pillars, right? And this is why we need to look at each one as a volume dial, right? If we set them all in maximum, this would mean the risk that is being exposed by this agent is now exponentially higher. And this follows the OWASP definition of excessive agency, right? Capabilities, autonomy, and permission. Now, let's go one by one and break down how can we lower the excessive cap in each one. First, if we look at capabilities, the goal would be to minimize the blast radius if the agent is compromising or hallucinating. That would be, for example, auditing every MCP server in your environment and every tool it exposes to the agent. And then we want to allow list only the specific tool the agent needs, right? In the previous example, we've seen how providing more and more capabilities to the agent might invoke additional risks. So we want to make sure that we provide the minimal amount of capabilities that the agent actually needs to do its job. And then we should focus on the non-atomic free-form tools. Those would be, for example, the arbitrary code execution or the unrestricted web access. Those tools are particularly risky. And the reason is that if the agent is compromised or hallucinating, they can use this tool to actually do whatever they like. They can implement whatever they want to do, given, for example, shell execution on your machine. So this is why we want to avoid using those unless absolutely necessary. Secondly, we can look at autonomy. The goal would be to ensure that any high impact or hard to reverse actions are always constrained. Those are the riskiest actions, and we want to make sure that we are able to classify the highly autonomous agents. Those are the YOLO modes. Sometimes we see this as in the coding agents that basically they can execute any tool they'd like with no human intervention, just like in the example that we've seen at the start with Pocket OS. So for those specific hard to reverse actions and high impact actions, we want to require human in the loop approval or employ behavioral guardrails that evaluate each one of those actions against the specific defined policy or code of conduct, right? It means that, for example, if I'm performing some financial operation, I want to make sure that it's following a predefined rules, or maybe there's a human who's approving this. Otherwise, this should not fly by just without any restriction. And then finally, the harder to implement but the most robust defense would be to block suspicious agent behavior. Now, this is multifold. The first step would be to get enough observability on the agent behavior and to audit anything it does. So, the first thing you need to do, if you don't have it today, is to make sure that the activity is recorded and any action it's doing, it's actually being saved in a specific read-only database, as well as what identity it assumed at the time that it was executing this action. Now, after you set the specific auditability and traceability, you're also able to establish a baseline of the agent behavior and know what it usually does. And then you can use this to actually identify suspicious behavior by looking at the anomalous behavior at runtime. So this is the hardest to implement, but definitely something you should look at. And then finally, permissions. The goal would be to enforce any list privilege enforce list privilege on agentic identities. Now, when we look at agentic identities, it breaks down to roughly four. First would be if the agent is working on behalf of a specific end user, they're using their identity. And now for this specific action, it embodies the humans to actually fulfill its request. The second type of agentic identity would be a static machine identity. Those are usually the service account that's being provided to the agent. Now, when we look at both of these, we're able to see that those are not the full picture. Any human being, any user that configures this agent might also impact its identity by changing its system prompt or its tools, or actually performing some actions to configure it in a different way that would change the way it behaves. And then finally, we would want to look at all the propagating agents. Agents now are not working on their own. There are a swarm of agents that employees are employing to actually do their job. So an agent might delegate a task to a different agent. Therefore, if the first single agent is very least privileged, but the second agent is very high privilege, that means that by proxy, the first one would be able to carry out very high privilege actions. So, what we should do is eliminate any overprivileged shared machine identities. And I have an example in the next slide. But when we look at it first, we should establish and understand if the the identity that this agent assumes is actually something static, like what I'm going to present in the next slide, or is it actually a delegated OAuth use on behalf of a user? So let's examine this example. Let's say that I created an agent and I'm providing it to my co-speaker, Galpnini. Now, I am the maker of the agent itself, so I have several options to provide it with my identity. I can use an API key. That would be a static identity, and no matter who is communicating with this agent, every time that it interacts with this resource, for example, Jira, it is working on my behalf because it's using my API key. But if I configure the agent to work in OAuth, that means that it's working on behalf of the end user. That way, although I am the maker of the agent, it is actually requesting the permissions of the user that it's interacting in. It is always working on kind of like behalf of their scope. So if we'd go one slide back, what we want to do is to eliminate any shared machine identities and to move into those delegated user scoped authentication rather than some form of static identity like the API key. And then finally, we would want to scope privileges to specific intent. So for example, I may be providing this agent with a specific permissions to do something, but it doesn't mean that it can invoke this hard to reverse action under any intent, right? So let's say that I have a customer support agent. It has the capabilities to provide a refund, a financial capability that is very hard to reverse. Maybe I'm authorizing this agent to do so under specific intent and execution path after following some sort of control and not under any circumstance. So you would want to scope those hard to reverse actions to specific intent and execution path. Now let's see how I employ this no excessive cap framework into a real story of me trying to get into RSA this year. Now, I live in Israel, and at this time it was very hard to get out of the country, and the flight was just outright canceled. As an AI enthusiast, I wanted to employ Claude to help me find an additional flight ticket. So I used Claude and I wanted to provide it with capabilities to control my Windows machine. Now I opened the extensions tab in the Claude and I saw that it has specific tool that allowed it to run arbitrary code over my host. So any hallucination, any compromise might be actually running something on my own host to, for example, install a reverse shell. At this point, the capabilities was too high to the maximum, and I wanted to lower the capabilities. So I chose a different MCP, a Chrome control. This would be providing it slowly a control over my Chrome and not my whole Windows machine. I followed the tools and I saw a specific tool to execute JavaScript, just like Galpini just mentioned before. So I blocked it so the agent would not be able to execute that. And then secondly, what I did is look at the autonomy of the agent. And I made sure that any capability that is actually interacting with the Chrome would require an approval. This is a mean to lower the autonomy of the agent to actually make sure that it has a human in the loop on any hard to reverse actions. Now, I asked it to find me a ticket to RSA, and I asked it to go to get a flight from Skyscanner from Tel Aviv to SFO, and it immediately wanted to open Chrome to navigate to Skyscanner. Now I saw a big black button that I almost clicked for always allowing the agent to actually invoke that tool. That is how autonomy creeps work. It literally slightly increases the autonomy by users suffering from what we're gonna see, which is basically an approval fatigue. Now, if we go to the next slide, you can see that although I allowed it only once, it opened the Chrome, and on the right top side, you may see that it actually has my own identity. So those are my my logged in session that has my credit card already filled in, and my identity assumed from this browser. That is just to show that those pillars are not they have some overlap, right? I provided with capabilities to access the resource of Chrome, but my identity was already embedded in my browser. So essentially, by providing it access to Chrome, I already provided it with my full identity, although it didn't seem like any token or any specific NHI. Now it asked me to read the page, which is the pop out that we're gonna see here. And then I allowed it once, and then when you click the when I go to get it, it asked for me again, and again and again and again, until at this point I found out that there's no way to employ this agent without always allowing it to read my pages. But the question would be, what if on one day my credit card was in this DOM in this web page? I wouldn't want the Claude to read that. So there's very low amount of limited capability to actually provide it with selective autonomy. So at this point, I found this was just not too high of a risk for me. So I just decided to do this on my own. So this is an example of how each one of you can actually employ the no excessive cap framework to your own organizations. Now, if you want to read more about the full white paper Noma has published, Gal, Pliny, and I were working on, you can scan this QR code. I'm going to wait for a second for you to be able to scan that, as well as other blog posts and other resources that might help you adopt AI safely. And if you have any questions, you can feel free to reach out through LinkedIn or any other means through the NOMA website, and we're going to be happy to talk to you about how to adopt AI safely. Thank you so much. It's been a pleasure. Thank you for your time. If there's any questions, I'm going to answer them over chat.